This is an experiment for BSc 4th semester diffraction grating by normal incidence method. Diffraction grating is a plate of glass with very close parallel lines producing a spectrum by diffraction and interference of light. A diffraction grating is able to disperse a beam of various wavelengths into a spectrum of associated lines because of the principle of diffraction. The direction of these beams depends upon the spacing of the grating and the wavelength of the light so that the grating acts as the dispersive element. In this experiment, we are using a spectrometer whose least count is to be determined. Now, this consisting of a collimator and a telescope, and these two are being separated by a prism table and the diffraction grating element which is being mounted on the prism table such that it is mounted exactly perpendicular to the collimator. Whenever this is being exposed to the light, then these light rays which when passing through the grating element will be observed within the field of view of the telescope, and this is the position of the slit is to be adjusted till we get a well-defined image of an object within the field of view of a telescope. So when we observe within the field of the view of the telescope, this is the nature of the image we are going to observe within the telescope field of view, and this reading is to be recorded as the direct reading of the slit. So when we record the direct reading of the slit, now the telescope is to be rotated by 90 degree and fix the position of the telescope, and at the same time the position of the prism table is to be rotated in a direction opposite to the telescope such that we observe the reflected light of the light which is to be observed within the field of view of the telescope. That means we have to rotate the prism table such that till we get the reflected image within the field of view of the telescope. Now record this reading as x dash. Then now again the position of the prism table is to be rotated in a direction opposite such that it moves by either plus 45 or minus 45 such that it is come back to its original position, and at the same time it is now mounted exactly perpendicular to the collimator. Whenever this grating element which when being fixed exactly perpendicular to the collimator, then it is set for normal incidence. When it is set for normal incidence, the position of the prism table is fixed. Now we have to rotate the telescope in the direction towards the grating element where we observe the diffraction pattern such as the first, second, third and so on. We are going to observe the fringe pattern, we are going to observe the colored pattern which is being represented. Now you are going to notice this is the pattern, colored pattern which we are going to observe, and in this colored pattern we have to record for the second order the colors such as the green and blue color. That means we are observing that it consisting of blue and green colors which is being observed here, and we have to record these readings on this the spectrometer. Now you are observing the readings of this particular experiment. First we have to record the direct reading of the slit that is given by x, that is found to be 115 degree. Now we have to rotate the telescope in a direction perpendicular to the collimator, then it is taken as y, that is given by say 205 degrees. So when the grating element is moved in a direction opposite to the telescope, now we have to observe the reflected image, and we have to, when we observe the reflected image, record this vernier reading as x dash, and that value is found to be 65 degree. And when this particular which is being rotated perpendicular to the collimator, that is to be recorded as y dash, that is given by x dash plus or minus 45 degree. That is found to be equal to, now it is moved by minus 45. So 65 minus 20 is 45 is 20 degree. 65 minus 45 is 20 degree. And these are the observations. The number of lines per inch of the grating element is 12,500, and grating element that is to be calculated by using the formula D is equal to 2.54 by N. that is found to be 2.032 into 10 raised to minus 4 centimeters. And this is the readings which are being tabulated on a tabular column. This consisting of order of the spectrum, left side vernier, right side vernier, and 2 theta, mean 2 theta and theta. And we are calculating for first order as well as second order for blue and green color. And these are the readings that are being recorded here. And finally we have to calculate theta. And this is the calculations. This is the first order. For the second order, we are calculating wavelength of blue and green for the first order, and here we are calculating what is the wavelength of blue and green for second order, and finally we are calculating what is the mean wavelength of blue and mean wavelength of green line. These are the readings which we are calculated.